Hello again, everyone. This is going to be a video on the second collisions worksheet. It's going to be very similar to the first one, where I will work out some of the problems and then leave the rest of them for you for homework. So this time I'm going to look at the problems that I've written down up here. So two of the parts to problem number 1 and then problems 2 and 5. So if you want to go ahead and give those a try on your own first, you can pause the video now and try to get the answers, and then you can come back and see the solutions. Okay, so to start off with, let's look at 1C. This is another collision problem. So we have two objects moving to the right. One of them is moving faster, so it's going to collide with the other one from behind. And then, judging by the picture here, the two objects stick together and move with a single velocity after the collision. So again, the way we solve this is the same way that we did in some of the problems on the first worksheet. We want to first calculate the momentum of each object before the collision and then set that equal to the momentum after the collision. So here we have two objects. The first one has a momentum of 10 times 6, mass times velocity, so it would be 60 kilogram meters per second. The second one has a momentum of 9 kilogram meters per second. So the total momentum before the collision will be 69 kilogram meters per second. And that must also be equal to the momentum after the collision. All right, so after the collision, we just have a single object. So just treat this as one object with a mass of 13 kilograms. So the momentum is going to be the mass, 13, times the velocity. So if 13 times v equals 69, then the velocity is going to be 69 divided by 13, which is about 5.3 meters per second. All right, so there's one example of a totally inelastic collision, so problems A and B will be very similar. Part E is not a totally inelastic collision. The objects remain separated after the collision, so this one will be solved a little bit differently. But I can say the momentum of this first object is 3 times 3, so that's 9 kilogram meters per second. The momentum for the second one, be careful, this is mass of 2 and a velocity of -2. So the momentum here is -4 kilogram meters per second. It's negative because the object is moving to the left in this case, not to the right. So the total momentum before the collision, 9 minus 4, so that's 5 kilogram meters per second, which means that the momentum after the collision is also 5. All right, so we're going to have two separate momentum values in the after picture as well. This one we can calculate as 2 times 4, so that is 8. And that allows us to figure out what the momentum of the other ball after the collision must be. So if the momentum has to add up to 5, one object has a momentum of 8 units, the other one must have a momentum of -3, because 8 plus -3 equals 5. Okay, so the momentum of this object is -3, which means it goes to the left, which is what the picture shows. That's also equal to the mass, which is 3, multiplied by the velocity. So 3 times v equals -3. That means the velocity must be -1 meters per second. All right, so I'll work a couple on the second page. Number 2 says you have a brick which is placed on a 2.9 kilogram cart that was originally moving with a speed of 26 meters per second. And you're asked to find the post-collision velocity of the brick and cart combination. This is actually a problem which is kind of hard to recognize as a collision in the first place, because it's not a collision in the traditional sense that you usually think of. Here the brick is just being sort of gently placed on the cart. But we can still treat it as a collision. All right, so sorry about that. Say we have this cart here moving to the right at 26 centimeters per second. It has a mass of 2.9 kilograms. And then the collision is between a cart and a brick, which is actually placed on it from above. So this has a mass of 4.1 kilograms, and it is at rest in the horizontal direction, so it has an initial speed of 0. So that's the way we want to treat this collision here. All right, so each of these objects has a momentum. I'll write that in a different color, just so things don't get too cluttered. So the momentum of the cart is going to be 2.9 multiplied by 26, which is 75.4. The units here would technically be kilogram centimeters per second, but we don't really need to worry too much about the units here since they're the same. All right, so the brick has a momentum of 0 since it's not moving before being placed on the cart. So in the after picture, we have the cart with the brick on top of it. So they're moving together, which means we can say that the mass of the moving object is now 4.1 plus 2.9, which is 7.0 kilograms. And it's going to move to the right with some unknown velocity. Well, we know the total momentum before the collision is 75.4, so the momentum after the collision must be 75.4 as well. And that is going to equal the mass of the object multiplied by velocity. So our velocity is 75.4 divided by 7.0, and we get 10.8 meters per second. Correction. I have to use the same units. I was using centimeters per second before, so this will be 10.8 centimeters per second. So the cart was moving at 26 centimeters per second. When you place this brick on it, it sort of weighs it down. It's going to cause it to lose some speed, so it slows down to 10.8 centimeters per second. But the cart has the same momentum after the collision as it does before. It has less speed, but more mass, so those two things even out. All right. By the way, I don't know why I drew all this up here. I guess I didn't think I would have room for everything, but I can just move that down here. All right, so moving on to number 5. This is a collision between bumper cars. If you read the problem, it says that the bumper cars are both moving north, which you might be used to drawing as upward, but just to make this all fit on the page better, I'm going to make north mean to the right. All right, so we have one bumper car here with a mass of 255, and it is moving at 98 centimeters per second. And then that's going to collide with another cart that has a mass of 198, and it is moving also in the same direction at 28 centimeters per second. Okay, so that's my before picture. Afterwards, the carts do not stick together. So the cart that was in front, the 198, is going to be moving at 71 centimeters per second after the collision. So it picked up some speed by being hit from behind. And then that leaves the 255 kilogram cart, which will move in some direction. It might continue forward, but slower, or it might have actually ricocheted back in the other direction. We actually don't know, so let's find that out. Okay, so we want to multiply mass and velocity for each of these carts. So for the heavy cart, 255 multiplied by 98 gives us a momentum of 24,990. And then for the lighter cart, 198 multiplied by 28 gives us a momentum of 5,544. So if we add those two together, we get the momentum before the collision as 30,534. And that, of course, must also be the momentum after the collision. All right, so we can calculate the momentum of one of the carts because we know mass and velocity. So 198 multiplied by 71 gives us a momentum of 14,058. So now this is a subtraction problem. This number added to the momentum of the other cart must add up to 30,534. So you take 30,534, subtract 14,058, and that gives you a momentum of the other car, which is equal to 16,476. and momentum is mass times velocity, so that's going to be the mass, 255, multiplied by the velocity, which is what we're trying to solve. All right, so we just solve this equation here, and let me just steal this space down here. The velocity is going to be 16,476 divided by 255, which gives us a velocity of 64.6. And now, since I was using centimeters per second everywhere in this problem for my velocities, my answer is also going to be centimeters per second. All right, so it's a few more examples for you. Go ahead and try the rest of the problems on this worksheet on your own, and you can enter the answers into the It's Learning assignment. Thank you for watching.